Welcome to our class. In this video, we will learn some fundamentals of machine learning and look at some of the applications. Machine learning, commonly abbreviated as ML, is a subset of artificial intelligence, AI. It consists of algorithms, and algorithms are like little computer programs, which identify patterns in data in order to make predictions or decisions without being explicitly programmed to do that. So that is the key point. We're not explicitly telling it what to do. These algorithms are trained on extremely large sets of data to perform a task based on the training data samples. So the algorithm learns those rules automatically from the data. So by seeing enough of this training data, it starts to recognize what the data is meant to represent. And here is where machine learning differs from traditional computer programming. In traditional computer programming, the rules and logic are explicitly written by a person. In machine learning, the computer learns those rules from the data. Now, that doesn't mean to say that there isn't a lot of programming and coding involved. There is. But we're not explicitly writing the rules telling the computer what to do. Most of the AI applications we are using today consist of machine learning algorithms. So everything that we've looked at so far in this course, it is machine learning that enables it to do what it's doing. So some of the primary applications: fraud detection, identifying security threats, recommendations, customer service using the chatbots, which we've looked at, language translation, which we've looked at, data analysis, and very big with robotics. There are three types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is the most common type of machine learning. It is used for classification and labeling of data. The model is trained with input examples that are paired with desired outputs or labels. And that is what a data set is. It's an input and a label pairs, millions of them. When we talk about the model, we could be talking about a large language model, such as GPT-4, or we could be talking about another type of model. Again, these models are computer programs. They're called models. And in supervised learning, the model is trained to recognize a specific output based on a specific input. This is a very simple example. So if we want the computer to recognize what an apple looks like, we give it the input being a picture of the apple labeled with the word apple. Now, we would do this over and over again with a lot of different apple pictures, but with the same label. And over a period of time, if it recognized some variation in an apple, it would know that that's an apple. So by seeing multiple instances of this, it begins to learn what it is. So we can do this with text also. So here we have some input. The movie was amazing, the food was terrible, it was okay, not great. So if we wanted to train the model to recognize the sentiment of some content, we could give it different phrases conveying different sentiments with labels: positive, negative, neutral, and over a period of time, it would start to recognize what was positive, negative, neutral. Some use cases for supervised learning: forecasting product demand for an upcoming season, say in the sales industry. By training the model on historical sales data, labeled sales data, it can make predictions for the future. Another area, predicting where students are at risk of failing or dropping a course. Again, using labeled past performance data. So supervised learning is used commonly in making predictions, among many other things. We have unsupervised learning. Unsupervised learning is used for clustering and grouping data, so finding similarities, and by finding similarities, we can find differences, therefore anomaly detection. Okay, so the model is trained with unlabeled data, and it learns these patterns on its own. So supervised learning is labeled data, unsupervised learning is unlabeled data. So the goal here is to find the patterns, structures, or relationships within the data on its own. Here's a very basic example of unsupervised learning. If the input data was different types of this fruit, and there's only 2 fruit here, ultimately it could group them into commonalities, similarities. Unsupervised learning is highly used in the medical profession with identifying patterns in imaging to detect disease. It's used in finance for anomaly detection, finding unusual patterns that could indicate possible fraud. And finally, we have reinforcement learning. This is commonly used in decision making and robotics. In this area, the model is referred to as an agent. Okay, so the agent receives positive reinforcement when it performs a task well, negative reinforcement when it performs poorly. And by positive and negative reinforcement, we mean some kind of numeric value. Again, this is all part of the coding that goes into this, so these numbers are meaningful to the application, not necessarily to you or me. It enables the agent to mimic trial and error learning process that humans use to achieve their goals. Some use cases are in autonomous driving, processing traffic, route optimization. A lot of the social media platforms use reinforcement learning to decide what to suggest to us or to offer us. And this is done by studying our engagement in what we are viewing and in the hopes of giving us something that satisfies us. So overall, machine learning is used in most of the AI applications that are out there today. The customer service platforms, which use the chatbots, the voice assistants like Siri and Alexa, using natural language processing. Your financial transactions use machine learning. Machine learning is highly used in cybersecurity to train the models to identifying and responding to attacks and for fraud detection. Healthcare benefits very much from machine learning through pattern recognition to help classify diagnostic images.